Thanks, folks, for joining me again in our conversation about 21st century engineering. Um, I have a friend with me today, Jonathan Hasson, who I really renewed a relationship with after many years. Jonathan's a former student of mine, but he moved into the consulting environment, something that I've done parallel with what he's worked on. And his experience in the consulting environment and what it was when he entered it a few years ago and what it is today, I think is really worth sharing for those of you that are considering this profession or are in this profession. And of course, as you should be aware, the goal of doing this is to equip you with the skill set and the perspectives so that you can be a success. Whatever you define a success to be, that's what we're here to try and help you achieve. So, with that, Jonathan, thank you for taking the time to spend with us today.
Yep. Thanks,
Um,
James.
Truly appreciate it.
Yep. You're welcome.
If you would kind of give us a brief overview, a thumbnail, if you will, of your background and where you are today.
Sure. No worries. I'll start back early. And I'm originally from Mississippi, born and raised in Mississippi. Grew up in Clinton, which is outside of Jackson. Went to Mississippi State, got my bachelor's and master's degree in civil engineering at Mississippi State. And once I finished that in the early 90s, so I finished my master's in 92, um, got married, and then moved to Atlanta to start consulting. And in my master's degree work, I was doing a lot of advanced computing. I was working in the Engineering Research Center there at Mississippi State, one of the top engineering computing centers in the nation, and was able to really learn quite a bit from that experience to really kind of shape and mold my future going forward. But as any young engineer likes to think, our opinions are important. So I thought getting into consulting would be great because I thought getting paid for my opinion was an awesome would be an awesome deal. And it was a lot of fun. I started consulting, moved to Atlanta, worked with a company called Metcalf and Eddy, which many people will recognize from the textbook that they had. That's pretty much what everybody recognizes, the Big Blue textbook. And I was able to work with Metcalf and Eddy for about 6 years in Atlanta, doing water and wastewater consulting work. That was my desire. My goal was to be in the environmental side, water and wastewater specifically. And so I had a great experience with them, and was offered an opportunity about 6 years in when I started to recognize that for me, for my goals, my personal goals in advancement, my personal goals in maturing in the field, I wanted to do something different. And I was given the opportunity while at Metcalf and Eddy to transition over to an operations group that was a sister company of theirs. And that gave me an opportunity not only to transition my role to more of a direct connection with operators in the water and wastewater field, but also to live overseas. Lived in Puerto Rico for 3 years. Had a great experience there, and that opened up a lot of opportunities because I was able to recognize that operations groups need better tools. They need better ways of doing their work every day. And that kind of set a path for me for the next 25 years, excuse me, for the next 25 years after that to follow an operations management role back in the States and start to travel around the US. We've lived all over the US, Southern California, up in the mid Atlantic, and here now I'm in Birmingham, Alabama now. And it gave me an opportunity to really exercise that operations side of my personality, the curiosity there. And in doing so, I was able to manage, 50 plus people at any one time, 20 something states of operations from a services standpoint in wastewater. And then most recently in that role, about this is probably 6, 7 years ago now, I started to get the itch again, the itch to then my brain wanted to do something different. And I read a great book that talked about jumping to a new curve. Once you accelerate up your development curve, you kind of plateau. And they said to jump to a new curve, so I did, and I jumped feet first into product management, and product management meaning hardware and software in the water and wastewater field, and development of hardware and software. So that was a totally different experience for me. And in doing that, I've kind of ended up in the role I am now. And so I'm vice president of a software company, and I'm able to utilize all of that experience and all of those experiences up to now really develop and help to guide customers and utility customers in utilizing advanced technologies for their daily operations. And it's a really interesting track to get here, and it's one where when you look at it in hindsight, you can see all the steps that were in place to get there.
The the consulting environment that you're still in and that you started out in has changed a lot over the really the past decade, let alone the past century. And not that you're that old, or not that I'm that old, but I've read books, so I kind of know.
Right, right.
The idea is that this is changing. I'd kind of like to get your, or have you share with the listener your perspective on what consulting meant when you started out, what consulting means today,
Yep.
and how you see it changing or morphing in the years to come.
Yeah. Yeah. So early on in my career, so early 90s. So if you think, looking back at that, that was only 20 years after the Clean Water Act was passed. And so in that first 20 years of the Clean Water Act, the engineering community was spending a lot of time figuring out what we needed to do, what technologies we needed, how we can best support the utility environment, the utility companies and groups to do their job best to protect water. So when I entered into consulting at that time, um, after about 20 years, there were some very tried and true ways of dealing. This is primarily on wastewater, but tried and true ways of dealing with wastewater. And so with that, a lot of the consulting was working with with utilities to understand the problems they had, and then providing them with these tried and true solutions. So at that time, there was not a lot of um, what's the word I'm looking for? Not a lot of new things
Innovation.
coming out. Yeah, yeah. In terms of technologies. And so that was great. I mean, we had the tried and true, and using tried and true is great, but it wasn't as challenging. It wasn't as exciting as I hoped it would be. But as the industry has moved along, and now we're 45 years or 40 years after the Clean Water Act was passed, um, or actually 50 years now. Wow. So it's time's moving. So yeah, that reminds me. I've got 31 years in this industry, and it reminds me every day.
Yeah.
Now that we're 50 years past the Clean Water Act, we're having to look at different things. The problems that are coming up in utilities are different, and it's not necessarily what treatment processes to use. How do we protect the environment better? But more, how do we solve the problems that are of an evolving utility, such as all of these retirees that are leaving now, the workforce challenges that they're running into, all of the data that has been, for lack of a better term, dumped on these utilities from all of the instrumentation and IoT devices that they're able to get now. How do we use that to make better decisions? So it's moved from solving a problem to making better decisions with every day. And this is where I think, as an engineering in the engineering field, we have to start thinking more along how do we help utilities meet these daily problems as well as the larger problems that they have to deal with.
Yeah. Yeah, absolutely. To date me, which I kind of do just by being on camera, I got into this profession as an environmental engineer because we didn't even know what the basic equations for a biological reactor
Yeah,
were.
right.
And so it was very creative, very open ended. But as the profession matured, you started finding people settling into just applying the same old design.
Right.
The comment we kind of exchanged here recently was that I also grew up at that time, and I say grew up as in the profession, when EPA's approach was we know so little, we're trying to move so fast. If we have no data, we can ignore it. If we
Right.
don't know of a problem, there's no
Right.
problem, which of course
Right.
is nowhere where we are today. And if
No,
anything,
there's an abundance of data. That's right.
yeah, we data overload. Yeah, big
Right.
data, what we're trying to crunch through.
Right.
And I read a mathematics book. Actually, my youngest daughter bought it on a whim. She's an avid reader, and the basic premise was that if you have data that you don't want anybody to know, bury it in gobs of other data, and it will disappear. And you can
Yep. Yep.
basically hide people from the facts by giving them too many
Yeah. That's
and
right.
or the truth. So being able to sort through that's a real piece, a real
That's
issue.
right.
Of course, we're dealing with climate change and the issues of energy and the transition in our energy resources and how we apply energy and the whole carbon footprint issue as those all connect together. I guess what I'm hearing you say is that technology and data are really on the forefront of what we in the 21st century as engineers need to be getting a handle on, and we need to be doing it fast.
We do, and it's moving so quickly. So in my company that I work with, name of the company is Aquasite, and that the name is very descriptive of what we're trying to do. We're trying to provide insight and visibility into what I call the secrets that are hidden in the data. And when utilities, utilities tend to have very specific siloed data sets. They have SCADA data that comes from their operations teams. They have laboratory data from their compliance sampling that they have to do. They have other data that comes in from the real-time IoT devices that they may have, metering or rain gauging and things like that. And then on top of all that, with their GIS solutions, with their hydraulic models that they may build, there's all these different data sets that have been provided to them, but in many ways they don't know what to do with it all. They don't know, and it's no fault of their own. It's just it's all siloed, and there's never been a way to pull it together. And so being able to get it all together, so you start understanding the interaction of this information starts, and then filtering out the stuff that's not necessarily needed to answer the specific problem is really where our engineering thoughts need to be moving. That's where the engineering field needs to be moving, is not providing a solution just to give them more information. Information for the sake of information is fine, but if it doesn't solve a problem, it's going to go unused. And so being able to provide information in a way that helps to solve a problem today is really where the value is
Yeah,
that we're working in.
I couldn't agree more. The back 20 years ago, we were advocating for preventive maintenance, and we
Mhm.
started collecting data because we knew our infrastructure was going to fall apart in another
Right,
15, 20 years. Oh, guess what? We're there. But
right,
but that's not the topic. But the issue was we had all this data that we were collecting, but nobody bothered to look at it. Nobody looked at it in the sense of actually trying to figure out what the trends were, what the problems were. And I've changed my advocacy for more rather than preventive maintenance, progressive maintenance. The
mhm,
idea is not just looking in the past and trying to fix yesterday's problems, but trying to figure out where the opportunity to fix tomorrow's problems are before they become problems.
yeah.
And
What we call it at Aquaside is preventive and proactive maintenance.
proactive is another
It's
term.
getting in front of it before it becomes a problem.
Absolutely. And the other part of that, of course, is design. And I don't think we talk enough about how IT and all of this data can be applied to design of systems, not just management. we'll come back to that here in a second. But do you see applications for IT in the design world?
Sure. I mean, there's you can take IT as this giant umbrella over information
Absolutely.
and
Yep,
break
totally.
it down into multiple things. And so we break it down into things like OT, operational technology, or ET, engineering technology. And there's a bunch of other ways to break it down. But uh, what we as engineers need to be careful of is building engineering technology or using engineering technology for the sake of engineering purposes.
Mhm.
And we need to provide an answer. And I'm going to kind of keep going back to this same message. We need to provide an answer rather than here's a great model. There you go. Have fun with it. We need to say, okay, we've built the model. Here's what the model's saying, and here's why it's happening. Here's why it's going to impact your daily, your daily routine. And within the public utility space, um, adoption of technology and workforce transformation of technology using technology is a big challenge. That's a very steep hill to climb, and so there's a lot of work that needs to go in even after all the engineering design is done, engineering technologies put together, the work to then support the utility through the process of adopting that new information, that new technology, and using it.
What do you see as the biggest impediment to that adoption? If this is so slow, and I don't disagree, but
Mhm.
I'm looking to you as a resource to shine your light on what you see as the what's retarding what is so obviously needed in terms of being able to address today's and tomorrow's problems.
Yeah, some of it is lack of trust or slow to build trust in new technologies within the public utility space. And we see it in all a bunch of different industries as well. But the public utility space tends to be slower because they're concerned about security. That public utilities are concerned about information security just as much as banks and healthcare facilities are. So that level of trust needs to be supported and built over time. There's also a need for
Is it trust in the technology, or is it trust in the user of the technology, or is it a combination?
it's trust in the technology and trust in the information that the technology is
Okay.
providing. So if you look at um, you look at AI, let's bring that up. Let's drop that big
Well,
bomb in the
I was
middle of
going
the
to drop that
conversation.
bomb in a
Right,
second
right,
because if you want
right.
to
So let's
scare somebody
right,
today, just say AI.
right. So 2 years ago, so let me go back up a little bit. So our company has been delivering AI solutions, machine learning solutions as well into the public utility space for 8 years plus. And up until about 2 years ago, using the term AI was almost forbidden. Not we didn't forbid ourselves from using it, but you didn't want to use it because it would scare people. It would scare the utility off. Then ChatGPT broke out, and everybody starts to understand at least one facet of AI.
Yeah.
And so that has really opened up the conversation around that now. And so utilities understand, they say, okay, I understand that you need lots of data to learn from. Got it. I understand that with that data, you can use some algorithmic functions to predict something. Got it. Um, I don't
Which
know
is
if I
nothing
trust. I
new.
don't know if I trust you yet.
Yeah, we've been doing that kind of work our entire
Yeah,
career. I mean,
that's
there's
right.
nothing new about that. So go
That's
ahead.
right. That's right. Well, and the challenge now is how do we communicate that better as an engineer to our customers, to our clients? We have to be able to speak to them without sounding like an engineer, and I hate to say it that way. We can't overload them with techno speak. We have to speak to them from a very approachable um, in a very approachable way that is understandable. And technology is great, but if you can't communicate the whys, the hows, and the whats about technology, then if you can't communicate it well, then it's going to be suspect. It's seen as a black box that nobody understands. We have to overcome that. We have to be able to communicate that better within the utility space.
Okay. And agree. The communication piece is essential.
Yep. Yep.
You have to have the expertise, but you have to be able to communicate it in a way that is uh, friendly. I don't want to say warm and fuzzy. And I
Right.
guess because I just said I didn't want to say it, I said it. But the idea is that people are afraid. I call it the matrix effect. In fact, I've had somebody bring that up just in the past 3 days, where this sounds a whole lot like the Matrix, and it's like, well, no, not really. Though it could become that. That's not where we are. But yeah, this idea of computational strength that we apply in design and management is certainly valuable. It does require adaptability. It does. I mean, I know your background for another reason. As I was at the university when you were getting your degrees, and so I know you weren't trained on what you're doing today. So
Right.
continuing education, continuing to learn. I mean, I can't say that the PCs that you were using in your undergraduate program were anything to jump up and down about. They were probably a little more than a Commodore Xbox kind of
Pretty
system.
close. We got
Yeah,
excited when my roommate got a 20 megabyte hard drive for his computer. That was exciting.
yeah, yeah. I put a 5 meg hard drive in my home built
Yep.
Zenith desktop and tripled my speed.
Right. Exactly.
It wasn't computational; it was just
That's
IO.
right. That's
Yeah.
right.
Okay. Super. Let me pick your brain a little bit for those that are here. I think everybody has a perspective of the term, but I did want you to give me your perspective of what a digital twin is,
Mhm.
and the importance of that in terms of both design and operation.
Sure. So a digital twin in our business is anything that is written to provide another way of looking at a physical process or a physical system. And so it's a digital representation of a physical system. And that digital twin could be a hydraulic model, it could be a plant-based model, operational and process model. There could be a lot of things built into a digital twin, and our solutions also are digital twins in that they provide not only visibility into measured data, but also streaming KPIs or streaming
Mhm.
analytics that you're able to develop in real time so that the operator can then make decisions, informed decisions on what the information is being provided to
Yep.
them in that solution. You know,
KPI
someone
KPI being key performance indicator.
key performance indicator. That's right.
Yep. Yep.
And so, streaming analytics, having the computing power to deliver these KPIs in real time to an operator is very powerful. So here's an example. I'll give you a quick example of it. As this is how a digital twin can be applied in a treatment process. So as operators go through their role every day, their primary role is to maintain compliance of the treatment facility. That's the number one role, is maintain compliance. However, they have multiple other roles, such as reducing energy consumption, extending the life of their rotating assets, pumps, blowers, things like that. So providing them with real-time feedback of their decisions to run blowers 1 and 3 versus blowers 2 and 4 for an aeration process, we can give them information that allows them to make better decisions, such as this is how much it costs for you to run these two blowers in combination. You may want to consider running these other two blowers in combination. Or we can do things like provide them with information about running these types of pumps, these combinations of pumps or blowers is going to accelerate the end of life of these assets. And so there are, a digital twin is can be defined in many different ways. From a pure engineering standpoint, models are digital twins. From an operations standpoint, decision-based process models or decision-based process solutions are digital twins. So it really depends on the application for the customer.
Yeah. And I think the real key, and you hit on it several times, is it's in most ways it's real time.
Mhm.
It's this isn't taking archival data and running a model and saying, oh, that's what happened a year ago.
Right.
It's a matter of being able to be running it real time with real time data,
Yep.
and not and saying this is what must be going on, and therefore is that good or is that bad, and what do I need to be doing to either keep it between the guardrails, transportation term,
Yeah.
or
Right.
or get it back on track.
Yeah.
As it
Yeah. But the real some real power comes when you can combine that digital twin, that streaming real time information with historical information, and that's when you start to overcome the institutional knowledge, the loss of institutional knowledge within the utility with retirements and things like that. And you can start taking a look back and saying, okay, well, when this happened last year, what did we do? What was the decision made? And that way you're able to overcome that loss of that knowledge via, the silver tsunami, as they call it.
yeah, to me, that's really where the advantage of true AI comes to. When
Mhm.
you have the historic data and the current operational data, that the machine learning piece, where whether it be supervised or unsupervised,
Yep,
the AI can recognize trends of the past, which we might miss,
that's right.
and
Exactly
apply
right.
those based on current data to trends of the future, projecting
That's right.
all within the context and confines of human supervision, but it becomes a real tool to bury through all that, again, that horrendous data set we were talking about, to help me make better decisions about what I should be doing today and tomorrow.
Yeah. In many ways, AI can be boiled down to doing things a human could do, and but just doing it faster.
Yeah.
And doing it in a way that provides that feedback in a much faster way than a human could ever do it. And
Oh,
that's really, what we're looking for in the utility space for sure.
yeah. Yeah. And the time it would take a human to even access the data,
Yep,
AI has accessed it and reduced it,
that's right.
and communicated what it's deduced. And
Yep,
again,
and
still,
recommend it. Yeah, that's right.
it's still up to us to make a decision of whether it's a valid judgment or not.
Yeah,
But
that's right. That's right.
well, along that line, there's a lot of conversation in our market, in our business, in our profession about the fact that, and I'm going to focus because, as you know, with my involvement with the American Society of Civil Engineers and civil engineering education and a number of other things that I'm involved with, been quite focused on the marketplace and workforce development.
Mhm.
And the data indicates clearly that we are underproducing, undergraduating, if you want to call it that, civil engineers into this profession.
Mhm.
Numbers can vary, but roughly speaking, it looks like we're producing about 5,000 fewer civil engineers per year than we need, and that trend's going to continue for probably another decade or more. So, with this workforce vacuum that's being created by retirements, as you mentioned earlier, and the lack of a workforce coming in to replace them, let alone the age gap in the market that's there now versus what's going to be coming through the door. We're looking for technology to fill that gap or do the things we don't necessarily need a human person to be doing. I wonder if you have a perspective on that based on your experience on how technology or AI or IT or ET or however you want to frame it, how we can use or how you see that being most effectively used in this profession, the engineering profession,
Mhm.
the water and wastewater industry, even more specifically, to address these workforce issues.
Yeah, it has to happen. I was at a conference a couple of weeks ago and was on a panel, and I was asked, do you see, and this is from an operational standpoint, but do you see uh, automation becoming a big force within the utility industry? And then the follow up question to that was, do you see it being accepted? And so, my answer, of course, was absolutely. We see automation coming in the utility industry, and that automation can be spread throughout the entire uh, gamut of the industry, from the engineering design to operations to all parts of it to management. But that automation is it's going to go back to what we talked about earlier. There's not a lot of trust in it now. So it's not happening yet, but it's coming and we have to be prepared for it. So, the new engineers that are coming, the new civil engineers that are coming into the industry, they have to have at least a level of understanding of technology, a level of understanding of how these advanced algorithms, the advanced ML and AI is being used in the industry, so that they can then leverage that to fill those gaps. And there's always going to be gaps where it's not only the water and wastewater industry; it's all over. There's gaps, and so being able to leverage or utilize the technology to support that is necessary. It has to happen. And so the the real challenge I think that young engineers have is being able to, I use this word lightly, master the engineering understanding so that it can then be applied to things that they are going to be faced with that they've never planned to be faced with, that they never thought of being faced with. And
Yeah.
it's going to accelerate. It's just accelerating every day. And having that firm foundation of understanding of engineering concepts, engineering theory, engineering um, understanding within the industry is critical, because they likely are the engineer that's coming out today is going to be totally different from the engineer that came back out 10 years ago. And the one coming out 10 years from now is going to be completely different. There may be a lot of automation in it by then. But I think the technology will never replace the human factor in engineering, because of the level of understanding, the level of just understanding codes, understanding design requirements, understanding the guardrails, as you said, that we have to operate within. If you let AI run with it on its own, it could go outside the guardrails really fast. So there's always going to be the human factor that we're going to have to use, and
The,
that's where the young engineer is going to have to understand. They're going to have to be able to live in that environment.
the other way I frame that and have on a number of occasions is, if you only design to the code,
Mm,
AI can do that all day. Technology,
that's
the
right.
computer models we have today can
That's right.
design to code. What we need is the human creativity to
Yep.
design better than code.
Yep.
We have a new world we're living in. The
Right.
the world of the 20th century does not exist for a variety of reasons, whether it be economic, socioeconomic, geopolitical, climate, natural resource, and the list goes on. We live in a very different environment, a very different world than existed just 50 years ago,
Right.
and there's no changing back, at least not immediately. I mean, if we
Yeah.
fixed all the climate issues and captured another planet and drug a asteroid onto the surface of the Earth without destroying ourselves, okay, we could get new resources and all the rest of that. But that's not today, and we
Yeah.
can't count on that today.
Right.
That's and I go back to what you were also saying. That good foundation that one gets in a college education is a starting point, is a foundation. It's not an ending point. You don't work 30, 40 years in a career based on what's on the history lessons that were taught to you as an undergraduate. Graduate school helps a little bit, but it's working in the workplace, it's being open to education, it's continuing professional development, and it's retooling, relearning, as you have done several times,
Mm.
learning new systems, learning new languages that really are impactful and allow you to be impactful in the things that you do.
Yeah. A prime example. I still have my master's thesis bound and on the bookshelf, and I pull it out every once in a while to remind myself just how much I've forgotten from grad school. because it was a bunch of computational fluid dynamics with a bunch of differential equations in it that I cannot imagine trying to understand now. But it gave me the foundation to move into a technology field that it gave me the working knowledge to get into a technology field.
Well, and that probably is part of the reason why, as you mentioned earlier, you came to a point in your life where you wanted to change curves.
Mm,
And part of that was probably to leave some of those ordinary differential equations in the dust and move
Yep.
over into more of a people management, project management application. A little less
Yeah,
technology, a lot more impact.
that's right. I mean, the name of that book was Disrupt Yourself. And I love that title because throughout your career, throughout anyone's career, there will be disruption. And we can allow it to happen to us, or we can take charge of the disruption and disrupt ourselves and challenge ourselves to do new things. And that's what's been. So I'm 30, almost 32 years into a career, and I'm still learning every day,
Yep.
new things, and that's what you have to do.
Yeah. Absolutely. Could not agree with you more. Well, we're coming to the end of our time together, at least for this segment. And I know you and I'll have other conversations in other environments over. Well, actually, I think we're supposed to get together in a couple of weeks, but that's
That's
another
right.
story.
That's right.
The I'm going to flip the script, as it were, and give you an opportunity to share with those that are watching at this time something that you would like to share. Is there, what do you see as a big issue in the water and wastewater area, or how can they be impactful in taking charge of their careers to become the best version of themselves, so that they can do the things that they want to do? Or maybe it's work-life balance. Pick a topic, and what would you like to share?
Yeah, I'm thinking about this since we first talked, and it really boils down to, I hate to say it this way, don't take yourself so seriously. You know, it don't take. I mean, life is serious. There's no doubt about it. But your life is in your hands. You have a way to kind of direct the course of your career. But you have to be willing to accept uncertainty. You have to be willing to accept disruption. You have to be willing to do things that are outside of your comfort zone. And many times in my career, I've been posed or I've been offered that opportunity, and it's one of those things where being married to a wonderful wife, a wonderful woman, Marty, she has been completely supportive of me in saying, "Okay, let's do it. Let's jump head first into this, see what happens." And so the challenge that I think young engineers would have in their career is being open to those options. I never thought I would be on an executive team with a software company. Never thought about that when I first started, but here I am. I never thought I would live in a Spanish speaking country and have to learn Spanish to conduct business, but there I was, and it was based on taking those leaps of faith, educated leaps of faith. Don't 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 jump in without really doing your research, but take those educated leaps of faith to disrupt your career, and it could prove to be very rewarding, and that's important.
Super. I appreciate you opening up to the extent you have, and you've been quite candid. I truly do appreciate that.
Yep.
Appreciate the investment of time that you've made in me today, as well as those that have elected to share their time with us. I hope those that are listening find our conversation of value. I often frame this kind of thing, much as I looked at classroom time when I was lecturing, as an investment on both parts. The instructor invests in the student, and the student invests in the learning that's coming. And the goal here is to make things better,
Yep.
to be a little disruptive in
Yep.
terms of just being satisfied and knowing that people at the end of the day are going to make change. You can either be part of the change, or that trite statement, I'm not going to go there. So anyway, again, I thank those that signed in. I thank you for sharing the time, and I wish you nothing but
I've
great
got one
things.
more thing. I've got one
Oh,
more
yeah.
thing to say.
Oh,
Civil engineering,
that's a
yes,
prerequisite now. There's always
that's
one
right.
more.
That's right. Civil engineering is one of the oldest engineering professions out there. And because of that, I think we're also going to be the ones that are going to lead the future of engineering, because we have such a broad base of knowledge that
uh,
it's going to be important going forward
yeah.
in whatever the new world is.
Well, in fact, there's some within our profession, civil engineering, who've become to reframe themselves as systems engineering.
Mm,
And the work that ASCE is doing in terms of future world vision and cities of the future, the IMAX
right.
movie, that are all with the idea that at the end of the day, it's a comprehensive yet learned understanding of what the future demands of us in terms of infrastructure in particular. That's gonna put us in that driver's seat.
That's
Albeit we've
exactly
always
right.
been there, we just haven't pushed on the horn button too many times.
Right. Right. Good deal.
Appreciate it.
Thanks for listening to the latest episode of the Infrastructure Network.